Okay, let me have a quick overview of options, stock options Greek. Let's start from the Black-Scholes formula. Since we've already been through the derivation, I will be brief. So the Black-Scholes formula is based on the stock price is going with a drift term and a volatility term, and then we do a Taylor expansion to the second order using the Ito's formula, and then we know that it has those type of dependencies of those variables: stock price, strike price, drift, volatility, time to maturity, and assume there's no arbitrage. Therefore the drift is interest rate, and then the yield is will be taken away from the stock, whereas it's y, and then there's the call option pricing, put option pricing, and then the d plus minus is expressed as such. Sometimes the d1 can also be expressed as d plus can be also d plus can be d1, d minus can be d2. There's different naming convention where y is yield, dividend yield, r is risk-free rate, tau is time to maturity, n is integration from a normal distribution, standard normal distribution from negative infinity to x. S is stock price, k is strike price. And here's a delta. The delta is the sensitivity of the option pricing to the stock change, and gamma is the sensitivity of the delta to the stock price. So the second order derivative of stock price. Theta is also named time decay. So pretty much it's just how much money you will how much the external value will lose over time, and the Vega, which is the sensitivity to volatility. Rho is the sensitivity to interest rate. Here's a brief plot of all of them, but I will just go through them quickly. Delta, the option price change due to the stock price. As you imagine, sorry, just do it brief. I just make it quick. Change due to time. The blue line is 10 days, green line is 20 days, red line is 60 days. So call pricing as the increase, as the stock price increases, the delta change increases along with it. And then for the put, same thing, but is a all negative number because as stock increases, you lose money because it's a put. Theta is a time decay is almost always negative. For call option, that's the case. For put option, interesting, it has a period deep in the money that is positive. Vega, sensitive to the volatility. As you imagine, the longer time it takes, the longer time you have, is less sensitive to the price of the stock as everything did of all the graphs, because there's a lot of uncertainty the further away you're having. But as imagine something just become more volatile, there's more money to be made if you have longer time. Imagine the cone of a certain, like of the boundary of a Brownian, or like a Brownian motion mean. Then you essentially yield this curve. Gamma is just a gamma just derivative of the delta. Intuitively think it just looks like this because it's a derivative of this plot. The rho, the longer the time, the more sensitive to interest, because of course the price of this option, the longer time it takes, the more interest will occur. And that's the overview of the option Greek. the formulas for most of them are all here. Just keep in mind the time decay chart. It should do this. And that should be correct. Theta, yes, theta time decay.